Hi everyone. So today we'll be covering dental waxes in one shot. This will be a very short lecture and it is mainly important for practical and one or two SAQs are asked in the theory examination as well. But overall, this is a very important topic because it is asked everywhere. It is a very small topic, but it is asked everywhere. So starting with the chapter, first we'll talk about the classification of dental waxes, how it is classified. Okay. So first, it is classified according to the origin. Right. So, dental waxes, according to the origin, we can have mineral wax, plant wax, insect wax, and animal wax. So, by the name itself, you can tell that mineral wax, so it is obtained from the earth crust. Okay. It is something that we get during extraction of oil, okay, like petroleum and stuff. And then we have plant wax, so it is obtained from plants. Then we have insect wax like beeswax, so it is obtained from insects. And then we have animal wax, it is extracted from animals. All right. Then we have the second, this is the first classification, and then we have the second classification according to use. So, where we use it. So, in dentistry, we have mainly three types of uses. First is the pattern waxes, then second is the processing waxes, and third is the impression waxes. So, where do we use the pattern waxes? Pattern waxes are used to basically create a pattern. Okay, so we use, you can say that we use these waxes to create something on top of that, okay, or to get a pattern from this. So first we have inlay waxes in pattern wax. So what do we do with that? So if we have a cavity like this, we use inlay waxes to fill this cavity up so we know what is the exact shape of the cavity, and then we burn this up by dewaxing and everything, and then we create a fast restoration which is of the same dimensions. Okay, so this is used to create a pattern that will be used to create a restoration. So these waxes are used to create something. Then we have RPD casting wax, which has similar function. It is used to create RPD. And then we have base plate wax. So we all have used it for teeth arrangement. We use it to create an artificial jaw on which we arrange our teeth. Okay. Then coming to the second, processing waxes. So processing waxes, they do not create anything. They are just used as a material which assists in auxiliary tasks. Okay, so it can act as a support or something. What it means, like example, contouring impression trays, sealing border of trays and boxes. So it is used as something auxiliary, which means extra. Okay, so it is used to provide extra support or create borders or something like that. It is not directly used as a restoration or for creating a restoration. It is used to support the process. Okay, so the first we have boxing wax. So you would have done your preclinical exercises in first year where we do beading and boxing. So that is the boxing wax. It is used to pour the cast. It has no direct function, but it is used to pour the cast. Then we have utility wax, sticky wax. So sticky wax is used to join two parts. If I have these two metal rods, I will put sticky wax in between, and then for welding, the sticky wax will keep this in place, and then I will weld these two rods. Okay, that is the function of sticky wax. Then we have impression waxes. So impression waxes, as the name says, it is used to create a precise detail of oral structure. So it is used to get the impression. We have corrective waxes, bite registration wax. These are the examples of impression waxes. So remember the first classification we had, it is according to the origin. We have mineral, plant, insect, and animal waxes. Okay, four very simple. Then we have according to use. So for the use, first we can get the impression. Second, we use something for processing. And the pattern waxer, it is used for fabrication of dental prostheses. Okay. Then the third classification, it is the ISO recognized classification where we have two type of waxes. So the first type is casting type 1 casting wax. Okay, for it is used for cast metal restoration. So we have class of this type 1, we have class 1 that is soft, and then we have class 2 that is hard. Then again we have type 2. So remember, this is class and this is type. So we have type 1, we'll use a pen, type 1 and type 2, and then of this type 1 we have class 1 and class 2. Then again of this type 2 we have class 1 and class 2. Okay, so the and class 3. Okay, So in class 1, we have soft, hard, and extra hard. So this is based on the where are we using it. Okay. So the type 2 is base plate wax. It is used for denture bases and occlusion rims. And we have class 1, class 2, and class 3 in this type. Now moving ahead to the inlay casting wax. So if a LAQ comes in from this chapter, it is mainly on inlay casting wax, 99.9% of the times. Okay. So talking about the inlay casting wax, where do we use it? It is used. It is one of the oldest waxes in dentistry. Okay, it has been used for a very very long time. It is used to create inlay crown and FPDs. Okay, it is first made in wax and then replaced by metal during casting. So I already explained you. For example, what is an inlay? So I have this cavity in my tooth. Okay, I will create, I will fill this cavity up. I want a prosthesis to fill this cavity up. So I will make an inlay using wax. I will fill this cavity up. Okay, then I will take this shape. So I will give it the exact shape of the tooth anatomy and everything, carve the wax. Okay, then I will take this wax out. If I can, and I will take this wax out. Mm, just a second. Right? I will burn it and I will invest it and then I will burn it. So I will get a mold. I will get a mold that will be shaped like a cavity, right? So imagine I de-waxed it, all the wax got burnt away, and then now I have a mold that is shaped like this, and I will fill this mold up with a metal, and it will get the exact shape of this cavity, and then I will this will be my metal restoration. So I will take this metal restoration back. Sorry, I can't just move it right now. So basically, I will take this metal restoration up and I'll fill this cavity up with this metal restoration. So that is the entire procedure of inlay and why we use this wax. Okay. So there are two techniques to this. First, we do this technique directly in the mouth. Okay. So we do it directly in the mouth and that is called direct technique. Okay. So that is called direct technique. For that, we use class 1 wax. Okay. And then if it is prepared on a die, so a die like this on a model, then it is called indirect technique and we use class 2 wax for that. Okay. So what are the ideal requirements of an inlay casting wax? This is a LAQ question. So when softened, the wax should be uniform. Okay. So it should not have granules or anything like that. It should be uniform. It should be the same throughout. There should be no graininess or hard spots. Okay. The color should contrast with the dye. So I want a different color. Imagine if the dye is yellow color. So if the dye is this is great. I don't want the same color. So if this is pink, maybe I want like a dark blue color or something so that I can contrast between the two and I can carve it nicely. Right. So it should have contrast with the dye and it should, to identify the margins of the restoration. It should not flake or crumble for obvious reasons. We want one solid, strong restoration. The wax should not chip, flake, or tear during carving. So the same thing. Okay. The burnout should be so at 500 degrees Celsius, it should completely vaporize. We don't want any residues. So I explained you the process, right? That we will be burning away the wax, so it should vaporize completely. We don't want any residues so that it will affect the shape of the restoration. If there are any residues, we want the exact shape of the wax. Okay. Wax pattern should be completely rigid and dimensionally stable all the time so that it does not change its shape or anything. Okay. It should be sufficiently plastic, slightly above mouth temperature, and become rigid when cooled to mouth temperature. So it is saying that when it is above the mouth temperature, it should be moldable. Okay. But when it is inside the mouth and when we have adapted it to the cavity, it should be rigid. Okay. Then the wax should have good flow when heated and set rigidly when cooled. So it should have a good flow, right? Because we want it to fill this entire cavity and it should be set rigidly. So it should not flow after it has been set. Now coming to the composition. So this is last in practicals and theory everywhere. Okay, very important. We have four major compounds. Okay, first is paraffin wax, then we have scissoring wax, then we have gum damat, and we have carnauba wax. So these are the four major compounds we use, and then these two, the candela wax and the synthetic waxes, these are substitute for carnauba wax. So first talking about these four major components, what is their function? So paraffin wax, it is the major component. It is 40 to 60%. Okay, it is the main ingredient and it establishes the melting point because it is the main ingredient. But what is the problem with that? It does not give you a smooth surface. Okay, so to get a smooth surface, we add other things. Now, what do we add? Firstly, we add scissoring wax. Okay, what does it do? Not scissoring wax, scissoring. What does it do? It partially replaces paraffin. Okay, so it will remove some of the paraffin and it will increase the toughness. So if it increases the toughness, it will be easy to carve because of the paraffin, the wax was not tough enough. Okay, it was getting flaky and it was moving away. Now this is making it tough so that it becomes easy to carve. It will only get away when we apply sufficient pressure. Now, the third thing we add is gum damar. Why do we add it? It improves smoothness. Okay, so it will improve smoothness. Therefore, it will make it more resistant to cracking and flaking, and it also gives luster to the surface. Okay, so we had one problem, major problem with the paraffin wax, that it was the main ingredient, but it was not giving smooth surface, and because it was not smooth, it was not hard enough as well. Okay, it was flaking. So there were two problems. We wanted a smooth surface and we wanted a hard surface. So we added scissoring to get a hard tough surface, and then we added gum damar to get a smooth surface which was resistant to cracking and flaking. We solved both the problems. Then we add the fourth ingredient, that is the carnauba wax. It is hard. Okay, it has a high melting point. So why did we add it? It decreases the flow at mount temperature. Okay, and it adds glossiness to the wax surface. So first of all, it makes it smoother and glossier, and it decreases the flow at mount temperature, that after the wax has set in, it should stay at the it should have the same dimension. It should not flow after the wax has set into the cavity. So it decreases the flow. Then, as a substitute for carnauba wax, we can use candela wax or synthetic wax. Okay. The advantage with candela wax is that its melting point is lower, but it is not as hard as carnauba wax. Okay. And then synthetic waxes, these replace candela wax even now, like right now, right? So to remember the components, you can have a mnemonic: PC, dye, Canada. Okay. And then in the bracket, you can add Supreme Court, like SC, because these two are the substitutes. So by PC, you can remember Priyanka Chopra. So paraffin wax. Then we have Scissorin. For Gai, you can remember Gum Damar. And Canada is the Carnauba wax. Okay. And for S and C, so it could be synthetic waxes and candela waxes. Right? So this is just an easy mnemonic to remember this. Now coming to manipulation of inlay waxes. So just I'm just telling you that this is not as important. I haven't seen many questions on this, but just for you to get an idea, or if it comes up as a short question, you should have an idea of this. Okay. So how do we manipulate inlay waxes? I already told you there are two techniques. One is the direct technique and second is the indirect technique. In the direct technique, we directly fill in the cavity in our mouth, and in the indirect technique, we use a restoration. So a dye restoration is used to fill in the cavity. Okay, that is the major difference between the two. So in direct technique, what do? We hold the wax over a visible flame. So what will we have? We will have a stick of inlay wax and we will have a burner. Okay, uh, we'll have a burner and we will directly hold the stick over the burner. Okay, we'll melt it, and this softened wax is shaped in the form of the prepared cavity and it is held under finger pressure while it solidifies. So some of this wax will melt. I will take it between my fingers. I will roll it into a ball and then I'll fill this cavity up with that wax. Okay, so I'll fill this cavity up with that wax. It will adapt to the shape of this cavity, and then I'll do all the burnout procedure and everything. Okay, so this is the direct technique. It is allowed to cool gradually to the mouth temperature. Why gradually? Because if we cool the wax rapidly, what will happen that there will be differential contraction. Because if I'm cooling it rapidly, then this area will cool first, and then this will and the bottom area will cool last. So there will be contraction, more contraction on the top surface, and the shape of the wax will change. Okay, and it will develop stresses, right? Localized reheating of wax with warm carving instruments has similar effects. So if I am reheating my carver to give it a shape, the shape of the cavity or the anatomical form of the tooth, it will have a similar effect, because then this portion will be warm and the bottom portion will be cold. So it will develop stresses and deform. Okay. And then what we do, we withdraw the wax pattern carefully along the long axis of the tooth. So I will have a sprue over here, and then I will withdraw it out of the cavity. Let's see if I can do it over here. So I'll withdraw it out of the cavity, and then I'll burn it in a chamber and develop a cast restoration. Okay. Now the indirect technique. What we do the same thing inside a lubricated dye. So I have applied some lubricant on the cavity of this dye, and then we can use the other method, that is the dipping method. In this, what we do, the dye can be dipped repeatedly into hot liquid wax. The wax is allowed to cool, carve, and remove from the dye. So maybe I'll have a tub full of liquid wax, and then I'll insert my dye in there. So if I have a tub full of wax, and then I'm inserting my dye with the cavity inside there, I'm taking it out, it is cooling, and then I'm again dipping it until it is completely filled with the wax, and then I'll take it out and carve as much as I want. Okay. Then what do you do? Softening in warm water. So this is the dipping method. Then we have softening in warm method. Then this is the second method. What we do, this is because we take the wax, and then we were over here, we were softening it over a flame. But here what we do, we take the wax, and then we have a tub of warm water, and we soften the wax in the warm water, and then we adapt it to the shape of the cavity and everything. Why it is not recommended? Because in this method the soluble constituents may leach out, and the properties of the wax will change. So some of the constituents, they may get leached out into the water, and the properties of your wax will change, as it says. Okay. Water will get into the wax, causing splattering on the flame, interfere with the softening of the wax surface, and distortion of the pattern of thermal changes. So basically, the water will get into your wax by this method, and it will cause distortion of your pattern. Adding in layers. So the wax is melted and added in layers using a spatula or brush. Self-explanatory. I don't think I need to go over it. And polishing is done by rubbing with a silk cloth. Okay. Then we have causes and prevention of wax distortion. Again, this is not a very important question, but it may come up as an SQ. So I'll discuss it. Okay. So if the wax is not uniform, sorry, the causes of distortion, what can cause the distortion? If the wax is not uniform, if it is not at uniform temperature, right, when inserted in the cavity, so some parts, so let's say some parts are colder. If I have this ball of wax, and maybe this part is hotter, and this part is colder, then this will flow more, and this will be a little rigid, right? So it won't flow properly. So when this happens, some part will contract more, and the others won't contract as much, and it will cause development of stresses. Okay. Then if the wax is not held under uniform pressure during cooling, then similar effect can happen. If the wax is melted and added in an area of deficiency, then it will induce stresses, because then we have one part that is hotter and one part that is colder. That causes stresses. Okay. During carving, if some molecules of waxes will be disturbed, then that can also result in distortion. How do we prevent distortion? We do minimal carving and change in temperature, minimal storage of the pattern. So we do the investment immediately. We use warm instruments for carving. Okay, we don't use very hot instruments. We use slightly warm instruments, and we don't use cold instruments as well. Okay, and store in a refrigerator if necessary. So then there won't be any melting or distortion. Okay. Now coming to base plate waxes. So this is again asked in the practical. You have to mainly talk about the uses and the classification, sometimes the composition as well. So base plate waxes, it is used for the following. It is used to make the occlusal rims. You would have already done that. Contour or tincture after teeth are set. So again, similar thing, it is used for teeth arrangement and it provides the shape of your denture. Okay, you carve the wax according to the shape of the jaw you want. Okay, to make pattern for orthodontic appliances. So it is used in orthodontics as well, basically. Then the classification according to ISO, sorry, we have type 1, that is soft. It is used for building veneers. So veneers are those transparent appliances that are used to give you a very nice smile. Okay, then we have type 2, that are hard. It is used to make it is used in mouth in normal climates. Okay, and then type 3, we have extra hard, so it is used in tropical climates like India. Okay, then it is supplied as a sheet of pink or red color. The composition, we have similar composition like the Inlay wax. We have paraffin or scissorin wax 80%, that is the major component. We have beeswax, remember that's an insect wax. Okay, we have carnauba wax. We have some synthetic resins, and we have microcrystalline, right? So this is it for the chapter. I hope you found it helpful, and I have covered all the major questions that are generally asked from this chapter. Thank you.